Hey, well, welcome everyone. My name is Joshua Stein. I'm from Sandia National Labs, and I am honored to host this webinar, which is being run by the Middle East Solar Industry Association. And being able to sit with this honored group of guests and panelists, we're going to talk about bifacial photovoltaic energy. And this topic is obviously pretty current now. I started working on bifacial PV about 6 years ago, and at that time it was a kind of a niche application. People were excited about it, but in the ensuing time, it's actually become the dominant and market leading source for solar energy, especially in the utility scale market. And it's especially interesting as a solution in the Middle East due to the high irradiance and solar resource. So I wanted to, as part of my career, I started working on with the IEA PVPS in the last 3 year period, and working with Christian Reisa from IEA, or from the Fraunhofer ISA group in Germany. We co-led a group, an activity as part of IEA Task 13 to develop a report that kind of gives an overview of bifacial technologies. And the report is shown here on the right, was co-authored by 50 experts from 11 different countries. And it's available from the IEA website, or you can get it at some of our partner institutions as well. It's freely available. And today we've invited some PV researchers and also representatives from our two sponsors, Trina Solar and Jinko Solar. And we're going to talk about kind of topics related to the main chapters in this report. And so the report is organized into sort of starting at the cell and technology discussion. So we're going to hear from Dr. Radovan Kopacek from ISC Constance, and he's going to talk about welcome to Radovan. Radovan's a well-known researcher in this field. He's referred to as Mr. Bifacial. I even have an action figure with him dressed in a cape, and so we're really lucky to have him on this panel. We're also going to talk about bifacial modules and bifacial systems and modeling. And so I'm going to, let's see here, go to the next slide. So some of our topic areas, and let me just introduce I introduced Radovan. We also have Jorg Athos from TUV Rhineland. He'll be discussing some important findings concerning the testing and performance of modules, especially in the MENA region. I'll give a brief overview on the current state-of-the-art in bifacial yield assessment modeling and some of the challenges. And then Mohammed Saideh, sorry if I'm mispronouncing your name, from Jinko Solar. He's going to give us a market overview of bifacial PV adoption in the MENA region, and then explain a little bit about how Jinko Solar is changing the design of bifacial modules using new materials and new concepts for that. And then finally, we'll hear from Asif Samad from Trina Solar, and he will discuss how Trina is designing bifacial modules and systems, and discuss a little bit about how you get better yields by combining, for instance, bifacial modules and trackers. And then we'll move into a general Q&A session and discussion. And it's an opportunity, if you have questions, please use the Q&A function on the Zoom meeting. And Radovan, why don't you take us through some of the recent technology improvements to bifacial cells, and what does the future hold?
Thank you very much, Josh, for the invitation, and also thank you the organizers that they invited me to give you some overview of bifacial cells and modules. And as Josh already explained, I'm working now since even before the foundation of ISC Constance on bifacial PV, like since 20 years, because we see actually that the development of solar cells and modules is ending up in bifacial technology. And this is what we have observed, and that's why we are organizing also since 10 years now bifacial workshops to bring in on the market. And now very briefly, like in 5 minutes, I will explain you how we got there and what will be the future. And first of all, just very quickly, let me explain you that now we all know it, PV became the new king of energy markets. So we have a tremendous decrease of the module costs. And of course, as a consequence, the LCOE costs now in 2021, we have average electricity cost from system of 3 cents per kilowatt hour. And now even there is a tender out there of 1 cent per kilowatt hour. So that's, let's say, the magical boundary. And I think that with new technologies, like with more bifacial and N-type technologies, we can go even below that. And so how is 1 cent per kilowatt hour possible? Very briefly, so like 10 years ago, the modules were smaller with lower efficiency and of course higher costs. So the modern modules look the following, and I think that Trina and Jinko will tell us more about that maybe. But in order to really come to the lowest cost, so it's not only the cost, but the modules are becoming more and more efficient, and that's the cause because we are going from aluminum back surface field to PERC, and now we go to N-type technologies in future. The module became bifacial, and this is natural because you are more or less passivating the rear side, and I will show you some cell details later. And of course, we have also, let's say, lower costs for balance of system, and also tracking came into the game. And that's why we can now reach this 1 cent per kilowatt hour. And so we are on a track to become really unbeatable. And let's say a couple of years back, there was only a choice between multicrystalline and monocrystalline aluminum back surface field. But when LONGi brought, let's say, the very low cost monocrystalline solar cells like ZZ wafers on the market, then PERC kicked in. And now it seems that there is a transition also to N-type. It will be not as fast as, let's say, aluminum back surface field faded out, but there are many advantages for N-type, and I believe this will come in future. So 3 takeaways: aluminum back surface field is history, PERC became #1, and N-type to come. So this is, let's say, the king of the energy markets. It's the PERC cell. And you see here that the aluminum back surface field technology is faded out, and now PERC became the new king. And we believe actually that the emperor will be N-type. And let's say all the tier 1 manufacturers have realized it, and they have this silicon heterojunction and TOPCon on their roadmap, but still PERC is #1, and we have to see in future if this will happen. And this you can see in this very nice graph that actually, like the last 10 years, there was a 0.6% absolute in solar cell increase, and aluminum back surface field had some limitations because you didn't have very well passivated rear side. So the logical consequence was to go to PERC, and then you can go to bifacial solar cells because the rear side is passivated. And then, let's say, the new technologies to come higher efficiencies is N-type. And not many know that this is, let's say, a graph of the voltage. So what we are doing, we are passivating the rear side and front side better, so the voltage is increasing. And I compare this, let's say, to the mobile technologies, like the past of aluminum back surface field is 3G, this is fading out. Now we have this, let's say, this 4G technology. 5G is on horizon, but we will get it in future, but we do not necessarily need it because we still have a powerful PERC out there. So here you have the list of all the solar cells technologies with their properties. So the king is still the PERC technology, and here you can see also the top cost of ownership for the cell. And if you want to see the cost of ownership for module, you have to add about 10 cents per watt peak. So PERC modules are at 20 cents per watt peak. And of course, the N-type technologies are a little bit more costly, but actually what it counts at the end is the levelized cost of electricity. So in future, it would make sense to put more costly modules out there because the LCOE can be better. And this is summarized in here, that actually that NPV will become the emperor of energy markets, going even below 1 cent per kilowatt hour. And that's because we have higher efficiency potential, the temperature coefficient is lower, we have higher bifaciality and lower degradation. So all these properties will then contribute to a lower LCOE at the end. And one degradation mechanism that is, let's say, also important for bifacial modules is you are opening the rear side. So there is some potential of new potential induced degradation so that the natrium sodium atoms can penetrate also through the rear side. So there are some methods how to overcome this. Of course, you can use, let's say, a very good EVA or polyolefin, and also, let's say, use also a transparent backsheet instead of glass. But this is what we will discuss later on. So that was my very brief summary. PERC is the king, and N-type will come. Let's see if tandem solar cells will be out there.
Thank you, Radovan. Just a quick question: when do you think, if you had to like project when you think this like transition to N-type will occur, what would you predict?
Yeah, so there are different scenarios. From Photovoltaic, for example, is saying that let's say in the next 7 years, this will be the transition where, let's say, after 7 years there will be no PERC out there anymore. International Technology Roadmap sees it slightly differently. They see it after 7 years, there will be 50-50, so still 50% PERC, 50% N-type. I think this transition will be not as easy as we saw it, like the aluminum back surface field to PERC, because let's say there are still other challenges. For example, in N-type technologies, you need a lot of silver. So this depends also, let's say, on the silver price, how this will go up in future and so on. So I would say we will see a slower transition than aluminum back surface field to PERC. But I think 10 years from now, 80% will be based on N-type.
Okay, great, thank you. All right, let's move on to, we can come back to this topic later. Let's move on to Jorg. I'm curious, what are some of the important findings that TUV has found concerning bifacial modules? What's the current sort of set of standards, testing requirements? Are there things that we need to do differently for bifacial modules than we're used to for monofacial? And I'd also like to hear a little bit about your experience in the MENA region.
Sure. Thank you, Josh. Like Radovan already said, bifacial is not new. It's been around for a long time. However, the standards haven't been really covering bifacial. I mean, only since this year we have a standardized bifacial standard test condition. And it's clear what should be the bifacial nameplate rating. Until last year, it was totally up to the manufacturers. Would they account for the rear irradiance or not when they put a label on the modules? So a lot of uncertainty for buyers, not knowing how can I rate and how can I compare one module to another. So I think some good work was done there in the IEC for this. When it comes to the testing and in the IEA report that you presented, there of course is extensive testing in there from various R&D sites around the world, different climate zones. Very a good read, I would recommend. However, it also says, I mean, a lot of these R&D sites were testing early technologies and benchmarking different technologies against each other, but on R&D platforms. So of course, when you look at the pure figures and you say, okay, one technology has a bifaciality of, I don't know, 90%, and it's getting a better yield by 20% compared to a monofacial, then what you shouldn't do is translate that to say, okay, now I'm going to build a PV power plant, it's going to be 20% better. just because those ratings, because there are many influencing factors. And now we come to the region MENA. I think it was on Radovan's deck also that, of course, some technologies have advantages in the temperature coefficient. And when you talk about energy yield, temperature is still the dominating factor influencing the energy yield. So low temperature coefficients are what makes a module in that region superior. When we talk about bifaciality and the module performance ratio, then of course it's one thing to buy a module that is better with these characteristics. It's another thing then, however, where is it placed and how does the system look? And then we talk about albedo, which is of course a clear recommendation from our side to do ground studies when you plan a system and make sure that you know also seasonal changes in the albedo and so on, because that's the dominating factor in the end.
Interesting. Okay. What types of data has TUV collected in terms of performance data in the MENA region?
Yeah, thank you. So we do have a test site in Tuval, Saudi Arabia, Kingdom. And we do have a test site in Chennai in India, which is subtropical, and we have a test site in Arizona, and then in Cologne, where our headquarters is. And so over the last 6-7 years, we've collected a lot of data. Of course, bifacial was only in the later runs, because if you look 5-6 years ago, there were not so many commercially available bifacial modules on the market. Now, of course, we see an increasing interest in our Tuval site, just because people need to also prove reference cases and show they have some data out of the region. So that's an offer we can make to collect the data, where we actually not only benchmarking the modules against each other on electronic loads, but we're actually collecting the spectrum, the rear irradiance, the temperature, and IV curves every few intervals. Yeah.
Okay. So, you said you're collecting spectrum, because that's a top topic it was presented at the recent IEEE PVSC, looking at how the spectrum of the backlight is different. I don't know if you've done any studies or have any thoughts on how that might influence kind of the way that systems are modeled.
Well, I mean, that hasn't been really analyzed yet. We do have the ability to do that spectrum measurement, but with the technologies, I mean, there was a focus on comparing the modules and collecting the data, and now we have weather data and spectral data over many years, so we can also simulate a lot, which is an advantage now. One finding that is interesting, maybe also to the audience, is that we did measurements on modules of the same type, and we realized that bifaciality, even within the same type, was fluctuating between ±5% in worst case. So even there, you have to make sure when you buy something, just don't take the first data sheet and base all your calculations and business plans on that, because the data might still not be fully recorded or presented in the right way.
Right. So I guess the point is that modules are sorted and binned based on their front side characteristics, but there can still be quite a bit of variability on the backside. So you shouldn't assume that the uniformity in the front side translates to the backside.
Exactly.
Yeah, it's interesting. All right, thank you. Actually, one more question. From the field data that you've collected, one of the advantages that's always posed about bifacial panels is the low soiling rates on the backside. Was that something that you were able to see on your field sites?
We did do various cleaning cycles, and including the back and the front side. We can say, I mean, it's not a difficult assumption. I mean, the front side obviously is soiling more. The problem you have is you definitely have to clean the rear side as well, and in particular also the sensors. I mean, a lot of sites, sensor cleaning was neglected on the rear side. But I can't say, you can, from our study, you could say, okay, if you clean the front side once per month, the rear side only twice per month, is really so site specific. And there's also, you might have these sand or stormy conditions where, of course, after that you would have to clean. no matter what your O&M plan was saying before. But of course, one thing is that you can take assumptions from sites that are close by, that have been operating for some time, that you have for your O&M plan at least some frequency. But of course, if there's a sand phenomenon, you have to clean front and back.
Yeah. Okay. Great. Well, thank you. We'll get back to some more discussion about this. In the meantime, I'm going to switch over to, let's see, my slides and just give you a quick overview on some of the factors. We've talked about site-specific nature of bifacial and the fact that actually the performance of bifacial systems are really dependent a lot more than monofacial on the design of the system, on the site characteristics, either through albedo. And one of the real challenges with modeling the performance of bifacial is that the system itself interacts with the environment in a way that affects its performance. And that's namely in the way that the system casts shadows on the ground. And those shadows then can reduce the amount of light that reaches the backside. And so the classic example is that if you were to put a monofacial or a bifacial module out in the middle of the desert and mount it, at latitude tilt or some other configuration and measure how much that module produces compared to a similar module that's monofacial with the same kind of front side rating, you would see very large bifacial gains. And some of the earliest studies, were conducted at very small scales and predicted, bifacial gains on the order of 50% in some cases. But when you actually start putting these systems in, with multiple modules, and as you can see sort of on the right here, where you have a 2-up portrait orientation, that whole system casts large shadows on the ground, and the modules in the middle of that array see far less light than, say, the modules near the edge because of these edge effects. And so scientists have been trying to, developing kind of different methodologies for how to represent this. And so there's two main types of models to try to get at what that rear side irradiance is. And what's interesting, I think, is that some of the really complex models, which can do a pretty good job of this in all different designs, are what are referred to as ray tracing models. And these are either reverse or forward ray traces, where you basically trace rays of light that come from either the sun or the sky and bounce around within the scene and eventually reach the backside of the module. And if you do this enough, you can create essentially maps of the irradiance. And the figure on the upper right is just showing a result of one of these ray tracing simulations, and it shows kind of the detail of the rear side irradiance on a single row of modules. Now it gets even more complicated when you add more rows, and in the report we actually have a pretty interesting section that talks about the sort of the sensitivity of, as you add rows, as you move to the center or to the edge of the array, how the rear side irradiance changes. One of the problems, though, with these ray tracing tools is that they require either high performance computing or clusters of computers to actually perform these simulations. To simulate in terms of like an annual yield would be very challenging and require a lot of computer support. So it's mostly used by researchers. And so models that are used for yield assessments use a different type of technique, which is called view factor or configuration factor models. And these were designed, the concept behind them are that different planes, sort of planar surfaces, receive light as reflections from different planar surfaces around them, and depends on how far away. And you can kind of think about if you're an observer at the back of a module at a particular cell and you see a shadow, what angular slice is that shadow represent? If the shadow is further away, it's a smaller view factor. And so as an example, the figure below kind of shows how this is done in 2 dimensions in PV-CIST. And it just talks about how all the different factors that are calculated in PV-CIST. The problem with this. It works quite well when you have large uniform systems. So for utility scale systems, it works well for the modules in the middle of the system. But it definitely, there are errors that propagate when you get to the edges of the system because it does not capture the details like we see on the upper figure. But the advantage is that it can run on a workstation, and this is what you primarily use for your yield assessments. And so the challenges here are mainly how these models can kind of scale or correct for some of the systematic errors that are inherent in the assumptions. So it's kind of interesting there's been a lot of work in the research of comparing these approaches. And one of the things I just wanted to highlight in the modeling report is we did a comparison. We defined a number of different scenarios, and these ranged from fixed tilt to single axis tracking to vertical, different in different regions. We used different climate, and we asked volunteers to simulate these systems, both the rear side irradiance and also the bifacial gains. And the plots on the right kind of show you an example of some of the mismatches between the models. So I think we got a very wide range of results. In some cases, the results differed by a factor of 2, which is really not acceptable. But I should point out is that we used a wide range of system designs. So while some models may work very well for kind of conventional single axis tracking utility scale systems, they may not work well for, say, vertical bifacial or fixed tilt if they haven't really been used for that. So I think that there's definitely what this study has shown is that there's quite a bit of difference in some of the methodologies, and so we need to going forward, it would be really good if some of the integrators and system owners kind of saw an opportunity to collect more of the performance data from these systems and provide those to researchers so that we can and model developers, so we can try to improve these models and get these results quite a bit more, so they all agree to a greater extent. So the next, I'd like to actually start inviting our sponsors to talk a little bit about some of the real world system data and technology experience in the MENA region. So Mohammed, can you kind of give us an overview of the bifacial adoption in the MENA region and talk a little bit about what Jinko Solar is doing in this area?
Yes. So thank you, Josh, and thank Misia for inviting us for this very valuable panel discussion with all esteemed experts in the industry. And also, I want to highlight before I start talking about MENA that the report that I want to thank everybody involved in this report, because actually it's one of the most comprehensive reports I have read about the bifacial modules and technology. It doesn't only talk about one aspect of the bifacial, but talks about many aspects like cell technology, testing, modeling, simulation, and optimizing the design. So I think it's very valuable. And what makes it also valuable for our region, that you have used many sites in the region, like Saudi Arabia and Egypt. So I think for people involved in the PV industry in our region, I think it will be a very valuable asset for them. Now, the very good thing about MENA that really started to be evolved throughout the years, that it shifted from being a price-oriented market into technology-oriented market, and this is with the support of everybody involved, developers like Masdar and Aqua pushing for new technologies, suppliers, clients, educating themselves and requiring more advanced technologies. So that's why when we see throughout the years how the transition from poly to monoPERC was very smooth in the region, and now the adoption of bifacial technology actually was also very natural. And now we've seen in major utility projects like in UAE, in Saudi Arabia, in Egypt, Morocco, small projects also in Jordan, in Oman and Qatar, that the requirement is always, bifacial. Now, there are many reasons for that. Now, one of the reasons that we started, asking for the price of kilowatt, and we focused more into the price of kilowatt hour. And that's why you've seen the last, maybe the now lowest top 10 lowest LCOEs, you will find most of them in the region. So I am really glad to see that our region is competing globally with others, although it's not as mature as other regions like in Europe, Japan, China, or US. But I'm really glad to see that the region is evolving and adopting in new technologies now. And also the combination of bifacial with trackers, I think this helped, both of them helped each other, I would say, because this resulted in a very good valuable reduction in the LCOE. And for developers, this is what really, at the end of the day, this is what really interests them. So now for all the major utility projects, I'm not talking about 100 mega or above, but even below 10 megawatt, we see that bifacial technology is required, and it's part of the standard requirement now we see. And even for smaller projects, we've shipped in Tunisia a smaller project with bifacial, in many other North African countries also. And also, I think also our region is really ready for this technology. We have huge areas actually in the desert that not invested at all. We have a very high irradiance. We have a sandy ground, which is very suitable. It has a very acceptable albedo. In some areas, we've seen that it's even exceeding the 40%. So this actually led to a very good implementation. And now we've seen, for example, for DEWA 5, 1 giga, it's bifacial. Most of the Saudi Arabia projects, RIBDO 2 and RIBDO 3, bifacial. Qatar, Oman, bifacial. Morocco, Egypt, bifacial. All the mega site projects. So I'm really glad to see that our region is in line with other regions globally with adopting the bifacial technology. And I hope that now we are also, as Jinko, we are not only shipping, but we are also working with many third-party authorities like TUV and iReason in Morocco, where we are testing also our modules with different technologies and different cell structures. So in Morocco, we are testing poly, mono PERC, half cut with different application. In Saudi Arabia, we are also testing double glass and transparent backsheet. So it's very, I think the market still needs more data. And I think more and more information. 2 years ago, we were lacking this amount of data. Now we have in our hands, and this is very good. And this study is also a very good tool for the people really to know and to understand about the bifacial modules. So I think with also 1 or 2 years to come, we will have a very solid data to really keep the bifacial in the as a mainstream technology. And as all the market predictions that in 2 or 3 years it will take more market share. Now it's estimated 20%. I think in 5 years' time it will be above 50%. So I'm really glad that our region, MENA, is catching up with this technology.
Excellent. I had a question because it seems like there's some specific environmental factors in the MENA region which provide challenges for building modules that will last for long periods of time. I'm thinking specifically the high UV loads and also the large temperature cycles that you see in the desert. Are there certain technological advantages to various module designs that you think about in terms of if you're choosing modules for that environment?
Yeah, this is a very good question because we know our region is very harsh in terms of environment conditions. And that's why if a module can survive in the desert of Saudi Arabia, for example, it can survive anywhere. So as you said, we have high UV radiation level. We have very high temperature fluctuations. We have humidity. Sometimes it reaches above 80%. So that's why the third-party testing is very important, and it plays a vital role. So we tend to send all the as many modules as we can to third party to be certified and to know exactly what situation. So for example, now, as we all know now, the EVA as encapsulant is being replaced with POE. This trend now is now for bifacial, it become essential, although before it was kind of, additional requirement, but now we see it's a necessity because of the humidity and during the damp heat testing that the POE is surviving and producing better performance. For example, now we have also for bifacial, we have the option of having transparent backsheet instead of double glass as the maybe 80 to 90% of the industry is offering. We have the double glass, but also transparent backsheet, I think. And this was tested also. We've done testing with Bifacial in US, with UL as well, in different sites in US, many of them in the desert. And where we were surprised actually to find that transparent backsheet has better performance in higher radiance area locations because of the heat dissipation of the backsheet. So especially if you are using EVA, for example, as an encapsulant, the transparent backsheet modules tend to have lower degree, operating temperature than compared to the double glass. So sometimes the temperature difference is 2 to 4 degrees. So this led to very reflected positively on the performance. And in some sites, we have third-party studies suggesting, showing that in some sites, actually, the performance at high temperature and higher radiance was around 2% between double glass and transparent backsheet. So I think transparent backsheet is a very good option also for our region. Double glass still considered as a mainstream, it still has better mechanical robust requirement if required. But I think for areas where there's no high wind load or snow or no high wind load mainly, a transparent backsheet can be a very good option in the desert conditions.
Yeah, that's really interesting.
And also, just to also, you spoke a little bit of the soiling. Transparent backsheet has something that anti-soiling property. So it performs also, the soiling on the backside for transparent backsheet is also less accumulated compared to double glass as well.
Well, thank you. Well, we'll hopefully get back to some of these questions. Finally, I'd like to welcome Asif from Trina Solar and hear a little bit about it, what Trina is doing to design bifacial modules and systems to get higher yields. And then also, I know that Trina also has a line of trackers as part of your company. So I'd be curious to hear what the strategy is in terms of optimizing those systems.
Thank you so much, Dr. Joshua. And thanks to Solar Arabic and Messia for hosting this session with all esteemed speakers in the group. So coming back to your question about Trina Solar, what is the bifacial module that we have? So like Mr. Hoge had already started, bifacial is not something that is new in the market. It's been here for quite some time. And what we have done is Trina has been in the market for over 2 decades and it's being grown from top-class photovoltaic module supplier to a company that is leading in PV and smart energy total solutions. Like for example, right now our portfolio includes PV modules, trackers, a complete solution, and also Trina Pro is a whole package solution that includes trackers plus the modules and a complete one-stop solution. So like I said, going back to the same point, so we have at Trina, we have invested more into R&D in developing the bifacial product by itself. We are committed to R&D and we have a complete team and which has led over 2,000 patents and of which 50% are inventive patents. So that's something that goes to be said. And coming back to the point of bifacial again, the product that we are speaking here is a 210 large wafer product that has been launched recently in 2020. One of the major advantages of the product is it has, because of the larger wafer size, there's more power output, and the 210 bifacial product by itself has 5 to 30% power gain than the previous models available. So Another advantage on this product is the product by itself benefits in more power, high reliability, and better savings as overall. And in terms of technology being used in these modules, we use the multi-bus bar technology, and in specific, the bus bars are thinner, which bring a lower shading area to the module, which increases the performance of the module overall. And because of this performance being increased, optical performance increases additionally as well. And we are seeing almost 8 to 12 volt, 12 watt in terms of power boost in these modules of 210 wafer size modules. So that is one of the key aspects of these products. And again, touching base to some other points that are affecting bifacial module gains, like module performance, it depends on various factors, and these are being evolved in terms of installation, site conditions, and other factors that are governing the module as well. Some of the main factors that are affecting the bifacial gain to start with are is one of the main factors is the reflective property of the ground, or so as what we call in the industry as albedo. The albedo is a main dependent factor that's depending on this one. And on a best case scenario, albedo as close to 1 will result in the most energy conversion from the rear side, and thus better additional gain is achieved in comparison to a monofacial module in terms. And another point on the albedo point is in terms of environment without vegetation, we have larger albedos because the vegetation absorbs sunlight. And in terms of hard conditions as desert, and also in terms of snow conditions, we have higher albedo. And as rule of thumb, bifacial performance is linearly related to the albedo availability. So the higher the available albedo in the desert conditions is benefiting the bifacial product by itself. And another point that has to add on to the performance gain of bifacial module is installation height. That again is a governing factor. So when it comes to bifacial product, as you know, the bifacial cell itself is capable of absorbing both on the front side as well as the rear side. So the most optimized height is something that has to be designed and kept in place, because the power gain from the rear side increases significantly between the height. So when the modules are installed at an optimal height, the power gain gets better outset of it. So this is another factor. And moving on to the next major factor that governs the power gain is the racking, or what Mr. Joshua was explaining, Dr. Joshua was explaining about the ray tracking methodology. So racking involves various sub-factors like, let's say racking by itself is the placement of the modules in the array and the distance of the array between the arrays and the GCR value involved in it. So from the ground level, the lower the module elevation, the lower the radiation at the backside of the module. So this is one of the main factors influencing the bifacial gain. So when the module elevation is optimized in terms of racking design, the radiation of the upper, middle, as well as the lower side of the backside of the backside of the bifacial module gets uniform. And this is a factor that optimizes the gain in the bifacial module. Coming back to another point that is also closely related to it is the GCR, or the ground coverage ratio. So the ground coverage ratio in terms of modules is the ratio of module area to the land area. So as the GCR ratio increases, the bifacial gain decreases. It's inversely proportional. So this again is a factor that has to be kept in mind. For an optimized solution using lesser form factor of the entire system, this is something that has to keep, given close attention to the GCR value. So overall, comparatively speaking, in terms of monofacial, bifacial has higher output, but there are optimizing factors that has to be taken into consideration as well. And on top of this, there are factors that even more add value to the bifacial product by itself. Like in terms of providing more additional gain to the bifacial factor again, we can give the best way to go forward is using bifacial module plus a tracker solution, which gives additional gain of almost 3 to 7% on the overall power output. So that's about the factors that affect the bifacial gain. If I have answered the.
Yeah, thank you. That was really, you brought up a number of different interesting points. One of the interesting things I find with the elevation or the height of the system effects, I think those actually, there's a lot of complicated relationships. The effect of height, it differs depending on the albedo levels, and it also differs depending on like where you are in the system. And so, one specific type of application, which I'm kind of curious whether it's being considered in the MENA region, are parking structures, covered parking structures, because just the nature of those, you end up having them high off the ground, and they also have to have lanes to drive between. So you get a lot of edge effects. And so I'm just curious if that's something that's being considered in terms, or if it's just in the MENA region, if there's more kind of commercial.
No, it was actually.
Yeah.
We have Abu Dhabi airport project actually with more than 3 mega of carport modules, and I think it will be commissioned very soon. And now it's very promising because, as you rightly said, the structure is there, the height is there. The distance are there, so you only utilizing the area. Now the main thing, the main trick about this is the uncertainty and the on the albedo and the backside gain, because you already have uncertainty related to the bifacial in general, but now when you have a carport, you have more uncertainty because you have a dynamic, I would say, dynamic ground. You have cars moving, you have different colors of cars also will lead to different reflective. So actually this was very tricky, but I think we can expect for this kind of installations, we expected around 7 to 9% of rear side generation for that project.
Only white cars allowed.
Yes, you just need to.
Exactly.
So we actually have we have only a few more minutes. We have a few questions from the audience, and I'd like to. One question was about since view factor methods are not very accurate in small setups, how can a designer or installer validate production forecasts? And maybe I'll just take this. I think one of the important things, if you are going to set up do a validation study or measure performance from a bifacial system, it's very important that you measure it not at the edge, and you try to measure it near the middle of the system. And so even if you're building a small test setup, you should have dummy modules on the edge. And there's a bunch of examples of how people have learned this lesson. So there's actually a publicly available data set from the National Renewable Energy Lab in Colorado, which is available online to actually utilize some of this, so you can download data from real bifacial systems and backside irradiance values. Let's see here, there's a bunch of questions. I wanted to, one of the big things that's actually coming in the industry, and I wanted to ask Radovan this, we hear about it, in a lot of the trade journals, is the move towards larger PV modules. And can you talk a little bit about, why, sort of inform people why modules are getting bigger and maybe what some of the implications of larger modules?
Yes, so actually the large modules topic started also because the solar cells were getting larger and larger, and that was because PERC came to its efficiency limits, and in order to make it cheaper, it's quite interesting to produce a larger cell in order to increase the throughput per watt peak. And then, of course, there was a possibility also to make larger modules with such solar cells. However, of course, it doesn't make sense to make it large as possible, but only as it makes sense. And then, of course, let's say the weight of the module plays a role, and so on, and also how exactly the trackers can handle these large modules. So more or less, there's a trade-off. If you make the module large, let's say you have lower installation costs for that. But the thing is, will such a module withstand the wind load and so on. So larger is necessarily not always better. It has to be optimized to the size or to the site where you are using it.
Yeah, I think another important piece of information is that, some modules can get to be cheaper by using thinner glass, using thinner frames, but you end up having to pay for that support somewhere. And so if you buy those modules, you need to buy tracker supports to actually hold those modules. And so you're going to pay for the support and the structural integrity. I mean, you want to pay for that because you need it. And so there's different strategies. You can build, very strong modules, which will be more expensive. They'll have more aluminum, but then you can use a cheaper tracker mounting structure. So it's interesting. There's a question here for maybe ask Jorg. It's talking about what sort of the best methods for measure. You had mentioned the importance of doing site surveys for albedo, because I think we all agree if you had to pick one parameter that was related to the site that influences bifacial performance, it's going to be the albedo. Can you talk a little bit about what are best practices for measuring site albedo?
Sure. Well, I mean, it's one thing I mentioned before that albedo might be at some places be seasonal. Well, that's not necessarily true for most of the MENA region, but mind you, it might still be, because you have plants growing in the desert, and that changes the albedo every now and then. And also, you have to take into account that we're now talking about very large installations, and the albedo is not going to be the same over the whole place. You might have rocks in one area and completely sandy in another. Even also the sand color changes, the rock color changes. So ideally, you would scan the whole area and do an average. But on the other hand, of course, it makes also no sense to have the albedo of the ground and then you put your system there. As you stated, the system itself will put shade and change the albedo. So it's not a straightforward thing. But of course, the starting point is to do the albedo at various points in the site, and also get a good understanding of that. Then the rest will be done by the simulation softwares that can take into account that shading effect depending on the height that also was mentioned by Trina. The standard that is widely used for these on-site albedo measurements is an ASTM, a Northern American standard. It's 1918-16. It's more or less a tripod that is put in the place and at a certain height where you measure with a pyranometer top and bottom irradiance.
Okay. Have you evaluated? I know there are some products, like I know SolarGIS serves up a kind of a global product of sort of regional albedo measurements. Do you have any comments on what the balance of using site measurements versus, say, purchasing satellite data?
Yeah, I mean, if you look at satellite data, same is true doing inspections with drones versus basing your assumptions on satellite data. First of all, satellite data is not always up to date. It might be a couple of months old. It might be only a moment in time. Again, if you do a wind farm, for example, you would be required to measure on-site the wind conditions over a period of time. In solar, somehow people get away with just doing moment of time analysis. So I would always say, if you want to have a proper business plan, you should do site measurements.
Okay. And we have only a few more minutes, but I wanted to kind of look to the future, because I think a lot of people there's a lot, solar is a very fast moving field. And a lot of the hype, I'm just curious to kind of get some opinions. A lot of the hype recently has been on perovskites and perovskite tandems, and the promise that, it may allow us to get, efficiencies over 30%. Anybody want to comment on kind of what they see as whether are some of Trina and Jinko looking into this? There was an announcement, I think I saw an announcement last week that there's some partnerships in this area. I don't know if Radovan, you want to talk about what you think, or?
Yes, so actually I believe that N-type will come quite quickly, and this actually means in PV world quite quickly is that in 5 or 7 years we will have majority of N-type out there. Perovskite tandem, it would be a dream situation because you have a lower temperature coefficient, you might have a much higher efficiency, and of course you can also have bifaciality if you have like 4-terminal tandem and so on. However, let's say the perovskites are not yet that mature. So from my guts feeling, because we are organizing also tandem workshops and look at the perovskite, stability, reverse behavior, and so on. And I mean, PV is a very special sector. It has to have a product which lives at least 20 years. At the moment, I don't see it. I think it will take at least 10 more years that we see big portion of tandems out there. But of course, we have to improve. And then, so these R&D efforts are very important, but it will take a long time that we see it on the utility scale, at least.
Yeah. Yeah, I know Sandia is actually just, Sandia and NREL are both starting a project to start looking at some of the early technologies, mini modules, and develop some of these testing protocols and stuff. Mohammed, do you have any comments about this?
Actually, I'm in line of what Dr. Radovan has stated. Now we are now reaching the limits, the theoretical limits of P-type modules. Now there's some improvement on the bill of materials, on the encapsulant, maybe on the glass little bit. Now, of course, the gallium doping has also, been a very good help. But now I think we will see the next transition from P-type to N-type. Because N-type, there's a lot of potential we see in the future. And during last SNIC in Shanghai, we've seen that all the top suppliers were exhibiting N-type with two main technologies, TOPCon and IPC. So I think we are going to that direction. I'm in line, but I will be a little more optimistic than Dr. Radovan, who said in 5 to 7 years. Now, I hope in 3 years, we'll start seeing that N-type is getting more market share in utilities. Now, mainly for us, the N-type is mainly for specific market, for specific segment, mainly for US or Germany or Italy. But I hope we will see the transition. And I hope to see one of the reasons that P-type, we reached the limit of the PERC technology is really pushed, and it was a milestone. It pushed the industry. And I hope that we will see some more milestone also that will really push the industry from P-type to N-type. But as Dr. Radovan, I'm still in line of the silicon-based modules will be the mainstream, at least 5 years. And all the other technologies are still under development and needs more proven.
Okay. Yeah, do you want to say something, Asif?
Yes, just to add a point here regarding the P-type and N-type. So yes, as Dr. Radovan said, N-type is up in the shelf, but it will take some time. But I do see there's TOPCon N-type product from our end, which is having a world-class cell efficiency. We are expecting that anytime soon. And coming back to the P-type, P-type will stay for some time because we are speaking about the 210 wafer, that is the end. So that's the future that was taken up. Now, looking on this front, it has been adopted, it has been evolved. There's a lot of R&D being done, and in fact, with Trina, the module by itself, as you were saying about the glass thickness, and the encapsulant and the backsheet has been optimized. In fact, it's not like a single product that's for the entire market. Like the P-type that's right now that's going on is being tested for high temperature testing. That's like the IEC 63126 for extreme humidity and high temperature testing. And also, there are high humidity regions that require PV solar. So there are places in such places, encapsulant is more POE based, and not because when you take high sensitivity or high humidity regions, the acetate in the encapsulant tends to react with the vapor present and oxidizes the panel itself. I mean, this leads to reliability issues. So in that case, the product by itself has a better encapsulant, and that has already been provided in those regions as well. So the P-type is evolving, and we are seeing the better of it right now. And in fact, we will see the best of it soon. And the N-type is up in the shelves, and we will expect to see some huge projects in the region with N-type.
Okay. Well, we're we're basically at the end of our time. I really appreciate this. Has been we could probably sit here and talk about this for the next hour or more. And I hope to see many of you at future in-person events and continue this conversation. I just wanted to point out that you did mention actually a really interesting point, which I think is very relevant for them, especially for desert regions, is there are new standards coming out and being updated that are actually addressing many of the issues. You mentioned the new IEC standard that's looking at extreme temperature testing. There's also standards that are looking at extended reliability testing, which are becoming kind of requirements for many financing agreements. So I think it's important. That's one of the things to lead to more confidence in new technologies is putting them through more tests and more appropriate tests, especially for site specific. And so that's actually a really good point to make. I think we're out of time. We're exactly at an hour. I'd love to thank our panelists. It's been a really fun discussion. I've learned a lot, and thank our sponsors and our hosts. So I think that will end this webinar. So thank you very much.